Okay, so yesterday you watched a video on physical and chemical changes, and I want someone to unmute yourself and tell me what a physical change is.
It's a change in color, size, or shape.
Good. It is a change in the physical properties, right? It is a change in color, change in size, change in shape. Give me an example of a physical change.
Breaking glass.
Breaking glass. Fantastic. If you were to take glass, I don't have any glass right now in my room, but if you were to break glass and just, or take glass and drop it on the floor, it shatters, right? And the glass goes everywhere. It's in little bitty pieces, but it's still glass, right? That is a physical change. Perfect. Now, I want someone to tell me what is a chemical change?
Change that forms a new substance.
Yes, so it is going to be a change that occurs, chemical reactions that form a new substance. It changes the composition of a substance. Someone give me an example of a chemical change.
Baking.
Baking, good. What's the other one?
Mixing chemicals like bleach and iodine.
Yes, so mixing chemicals, forming those chemical reactions, baking, burning wood, things like that, chemical changes. Now we're going to take what you remember about physical and chemical changes, and we're going to apply that to weathering, all right? Weathering is breaking down of rocks. So it's taking the big rocks that we find on the Earth's surface and breaking them down into smaller and smaller pieces. And we have two ways that we're going to talk about today of doing that: mechanical weathering and chemical weathering, right? Goes along the lines of physical and chemical changes. So let's see. I'm still learning my mouse directions. All right. So mechanical chemical weathering, breaking down that rock on the Earth's surface into smaller and smaller pieces. So that's the definition of weathering. Okay. We're going to talk about weathering, erosion, and deposition later this week, but right now we're just focusing on weathering, the breaking of rock into smaller pieces. So mechanical weathering is where these rocks are broken down into smaller pieces by external conditions. This means we are changing the size and the shape of the rock, okay? And mechanical weathering occurs most when it's dry and cold. Types of mechanical weathering that we'll talk about is frost heaving and frost wedging, plant roots, friction, and burrowing of animals. So the first example of mechanical weathering is frost wedging. What happens is water gets down into the small cracks in the rocks and it freezes. What happens to water when it freezes?
It expands and pushes out the rock.
Yes, it expands, right? So water gets in the little cracks, it freezes, it expands, and it pushes against the rock. So it makes these cracks bigger. Now more water can get in those cracks. And when it freezes, it expands and pushes those cracks even further apart, right? Until the rock gets broken off. Frost heaving is the same concept. Okay? Water gets in the little cracks, it freezes, it expands, but instead of pushing outward, it pushes up. It heaves that rock up. So this patio stone here is being pushed up by the expansion of the ice, the water freezing underneath it. So frost wedging, frost heaving, same concept. Frost wedging, the water is going in the cracks and like a wedge is pushing them apart. Frost heaving, it's up underneath the rocks and it's pushing it up. Plant roots. Now, when plants are small, are their roots really big or are they really tiny?
Tiny.
Tiny, good. And those tiny roots can get into very small cracks in the rock. And as the plant grows and the roots grow, then the roots are going to push the rocks apart, right? They're going to increase the size of those cracks. So we have this plant, this tree is growing out of the crack right there. And as it continues to grow, it will push that crack further apart. And then we have our big tree over here. The roots are all in the rocks and it's pushing those apart. Okay, friction, impact, and abrasion. This is where sediment, sand, small pieces of substrate are carried by water or wind. And when those small pieces of substrate hit against rock, it's going to wear that rock down, okay? So either by friction, right? We talked about friction before with the air molecules burning up the meteors. So you have those pieces of sediment sliding against the rocks, or by impact, right? Just hitting it over and over and over again. That rock will get worn down. The last one I want to talk about is the burrowing of animals. Somebody came into my thing. So the burrowing of animals can dig holes in rock or compacted soil. They do it for shelter. They might dig to find food, and that causes the area to break down, right? The rocks will break down, that compacted soil will break down. It won't be as strong. All right, any questions about mechanical weathering? We're just changing size, shape of the rock. All right, chemical weathering. It's the process that breaks down the rock through these chemical changes, creates a new substance, so the composition of the rock is actually changing. This occurs most when it's hot and wet. Mechanical weathering occurred most when it was cold and dry. Some examples of chemical weathering is just water. Over time, water will dissolve rock. We have the process of oxidation, where we get rust as a product. We'll talk about carbon dioxide that forms carbonic acid, and that helps to dissolve rocks. Some plants can produce acids as well. And then we actually have acid rain, right? Where acidic rain falls down from the sky and will cause chemical weathering. So water can weather rock by dissolving it. Happens over a really, really long period of time, but you would have water collect in depressions in the rock, and then it just sits there. And over time, it does dissolve it. So these pools that you see will get bigger and deeper as time goes on. For oxidation, you have iron combining with oxygen in the presence of water, and it causes rust. So if you think about leaving your bicycle outside, right? Or leaving any kind of metal outside and it rains, what happens to it?
It rusts.
It rusts, right? And if you leave that metal out long enough and it rusts enough, does it break apart?
Yes.
Yes, it does. So you want to always bring your bikes in, or if you have any metal out, you want to always keep it dry because eventually it will rust and it will get super weak.
I have a question. Can acid dissolve glass?
Some acid might be able to. I'm not sure what acid is, what acid can, but some acid can. Excuse me. So with rust, you can see kind of the ring here around the outside of the rock is red. that reddish orange coloration, that shows rust. Over here on our little cliff, that soil, you can see the orangey red color in it. That signifies rust. So this is showing a chemical weathering taking place. Carbon dioxide can dissolve in rainwater and create carbonic acid. And carbonic acid can weather limestone and marble. So this is how we get these underground caverns, okay, with the big stalactites and stalagmites. Carbonic acid drips through, dissolves the limestone, and you get these huge, cave formations, right? These caverns. Now, think about the surface of the earth on top of this cavern. Is this cavern going to be very strong compared to a solid piece of earth?
No.
No, right? If you've got stuff on the surface of the earth and you've got all this space under it, it's not going to be as strong to support what's on the surface as if we had a section that was just solid. So what do you think happens when enough of this gets weathered away and it no longer supports the surface of the earth? What happens?
It collapses.
Yes.
Sinkhole.
Sinkholes. Very good. You get sinkholes. The whatever's on top, the surface of the earth just falls down. So if you have a house on top and underneath is this cavern, your house is going to fall down, right? Or the cars, whatever's on top of the surface, whenever that underground cavern can no longer support it, it just collapses. It just falls down. Good. All right, living organisms. So we have in these pictures lichens, and they grow on rocks, they grow on trees, they grow everywhere, and they produce weak acids. These weak acids will break down rock, and they'll actually generate soil. We'll talk about that more whenever we talk about succession. But they chemically break down rock. Now, like I said, you can find these all over the place. If you go outside, you can see, I have my stick here. I don't know how well you can see it. But if you see all the little flakes there on my stick, that is all lichen, okay? It just covers rocks. It will cover tree trunks. It covers branches. And it will break down rocks. And the last one is acid rain. This is burning fossil fuels, coal, oil, and gas. Those emissions go up into the atmosphere. They combine with the water vapor that is up there, and it causes an acidic precipitation, right? It causes acid rain that drops down, and whenever that acid rain hits the rocks on the Earth's surface, it will weather them away rather rapidly. All right, any questions about mechanical or chemical weathering? Good. I am going to ask you a few questions. All right. I'm going to show you some pictures and ask you if it's mechanical or chemical weathering, okay? So once again, we're having a conversation, so y'all can unmute yourselves whenever you get ready to talk. All right, we have this big boulder, and it looks like it's been split in two. What is that, mechanical or chemical weathering?
Mechanical.
Mechanical.
Mechanical, yes. It was probably ice wedging, right? Because we don't see any trees growing up around it. So it's probably water got in the crack, it froze, expanded, more water could get in the crack, it froze, expanded, more water, and so forth until you have this rock pretty much cleaved into pieces. All right, what about this picture?
Chemical.
Mechanical.
It's chemical.
Oh, chemical. Sorry.
Chemical, yes. So it looks like the holes look like those little pools of water, right? We've got water there, and water is just dissolving that rock. So it is chemical weathering. Very good. There we go. What about our statue face?
Chemical.
Mechanical.
Mechanical. It's chemical.
Chemical.
Now, some people think it's mechanical because they think of like the wind and the abrasion, but this is primarily chemical because of the types of stone that statues are made out of, limestone, marble, things like that. You have that carbonic acid that forms when carbon dioxide mixes with water, and it's causing this. So you see in statues, the older statues, their details are not very sharp, right? They look very worn down because of the chemical weathering. All right, our big rock here, mechanical or chemical?
Mechanical.
Yes, mechanical. So we have wind carrying sand, carrying sediment, blasting up against this rock, and we end up with very strange rock formations as a result of that. All right, what do we have going on here?
Mechanical.
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 Okay, I heard mechanical. Did I hear chemical?
It's mechanical.
Does everybody say mechanical?
Mechanical.
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 Did anybody, listen, did anybody say chemical?
No.
Okay, it's actually both. Okay, so let's look at it. See the plant roots, right? Growing through the cracks in the rocks. That is mechanical weathering. Plant roots are growing into the cracks. It's getting bigger. It's pushing the cracks apart. Then, what color do you see?
Red.
Red.
Yes. What does that signify?
Rusting.
Rusting.
Rust, yes. So we have rust going on here as well. And rusting, that oxidation process, is chemical weathering. So in this picture, we actually have both mechanical and chemical weathering. What about this picture?
Chemical.
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 Yes. Chemical weathering. What type of chemical weathering do you see here?
Rusting.
Rusting.
Rusting. Perfect. All right. What about this one?
Chemical.
Mechanical.
Okay. This one is chemical, right? These are those underground caverns
Ooh, okay.
where that carbonic acid comes down and dissolves all the limestone. What about this one?
Mechanical.
Mechanical.
Okay. Do you just see
Mechanical.
mechanical?
Oh, wait.
Oh, is it both?
Some red. Yeah. Both.
chemical too. Chemical too.
It's chemical too. All right, so let's talk about mechanical first. We have the rushing water, right? The rushing water bringing sediments, impacting the rock. It's hitting up against all these rocks, and it's wearing them down. Now the chemical weathering comes into, you see our little pools, or holes that look like where pools of water were, and water that pools there dissolves it, right? So we've got chemical weathering going on. We've got mechanical weathering going on from the rushing water. It looks like you do have some instances of rust as well with the coloration there. So that would also be chemical weathering. All right, last one. My friend, the tortoise.
Science PP.
Chemical.
Chemical.
All right,
Mechanical.
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 it is mechanical. Yes, my friend, the tortoise is burrowing. Tortoises can burrow through almost anything. Like they can burrow through walls, right? If you ever have a pet tortoise, a sulcata tortoise, they will actually, dig through your wall in your house. So tortoises are burrowing, animals burrowing. This is a mechanical weathering thing. Good job. All right, guys. So you know about mechanical and chemical weathering. make sure you do your daily check today. And your next quiz is next Tuesday. Okay? So do y'all have any questions for me right now?
It's not about the class, but it's about school. So after the 9 weeks, what time will how will we know what time the bus will come?
That you will find out either from the transportation. It should tell you on the transportation webpage where you find your bus. It should tell you what bus stop you're going to and what time it'll pick you up.
Okay.